Hi guys, welcome to Learn Electronics Repair, and I have something interesting on the bench today. So this was sent to me by AliExpress. It's a AM signal generator, amplitude modulation. So this basically simulates a medium wave band transmitter really. There are a number of different versions of this. This is actually the cheapest version of it, which we see here. So €30 for this. This is the medium wave version, AM. There is another version which has the same AM, medium wave, short wave, 5 to 18 megahertz, and it also has frequency modulation as well on the FM band. Okay, we can see intermediate frequency or IF frequencies. So there's that version as well, and then there's another one kind of in between, which is the AM FM model. So I thought I'd actually have a look at the cheapest one, although if you guys are interested in this, maybe we could have a look at that one as well. Okay, let me know. But first of all, let's get on with this. So the first thing I thought about this is this looks exactly like the sort of project I would have built in the 1970s or 80s. Yeah, it has a paper tile stuck on here, big control knob, yeah, and it's all in Chinese, and there's only a Chinese version of this. So first of all, we need to have a look to see what this says. Yeah, what's it trying to tell us? So that is not difficult these days. Google Translate, Chinese to English, and I choose camera. High frequency amplification, open. So maybe have an on off switch, I'm not sure. Audio amplification, so I think this is RF output basically, and the audio amplifier or amplification level. We have some things down here. High pitched sound external audio. Okay. This is saying medium wave signal generator and the frequencies. So having used the universal translator, you know, our Star Trek doesn't look so sci-fi these days, yeah, the things we have. Let's have a look at the device. So this is battery powered, 3 batteries. Let's power it up, let's feed some audio in, and let's have a look to see what comes out of it. This came with a cable, stereo audio by the looks of it, okay, and an instruction manual, which, would you believe it, has a schematic on it. I mean, how often do you buy something these days that has a schematic? Yeah. So this is all in Chinese. Obviously I could use the translator again as I did before. Yep, everything is in Chinese. But I think it's fairly simple to work out how to use this. So let's just give it a go and see what happens. I've plugged the supplied jack lead into here, connected the ground of my oscilloscope. Let's have a look. So we'll just look on the output of this. Yeah, and there we have a signal. So this is connected to the computer, but there's no audio playing at the moment. Yeah, changing the frequency quite happily. Amplitude, okay. So the maximum amplitude is actually fairly low, but you would expect for an RF signal to be fairly low, I guess. Really, let's see, what do we have? We have about, well, we're on 2 volts per division actually, because I'm on the times 10, so it's a bit over 2 volts peak to peak, that actually. Let's try giving it something to modulate. So I'll try a sine wave, just using one of the free online audio signal generators. Okay, so I've attached a lead, or 2 leads really, because it's stereo output on my mixer. Okay, I'm using the online signal generator, the free one, to generate a 1 kilohertz tone. And look, we can see we can modulate the signal. Eventually it kind of seems to go into some sort of clipping there, but yeah, we can modulate the signal all right. Let's see if we can trigger any better than that on it. There. Okay, so amplitude modulation. And my scope, well, you can see how the scope's behaving, yeah. There. Let's just put some music instead. Okay, what do we have? You can't hear it. I'm just feeding it into this. I'm not feeding it back into my speakers. But you know, anyway, copyrighting that with YouTube. Let's see, so you can see, yeah, you can still see something there. Okay. So that's how my analog scope is displaying the AM waveform. Now, one of the reasons I was interested in buying one of these actually is because apparently a lot of digital scopes don't like these sort of things, and I thought this might be useful for conducting reviews. So let's just put that into my Finersi bench scope and see what that thinks of it. Well, we have something happening. I'm going to press auto. We have something, okay. And we get that, which this is with the 1 kilohertz tone. In fact, to be quite honest, the waveform itself doesn't look so good. I have the scope probe clipped on, same as I did with the other scope, the analog scope. Yeah. We can adjust the frequency, that's what you would expect. Much noisier though. And then we switch the modulation on with the 1 kilohertz. And we've got that. The two scopes certainly display very differently what we see. That's interesting. Let's see how my Rigel scope behaves. So that's without the modulation. Okay, that's fairly clean. I'm actually using the same scope probe I had on the Finersi, by the way. I've just kind of swapped it to the other scope basically. Yeah, that kind of like strange shape in the waveform, I had exactly that on my analog scope as well. Just adjust the frequency, up, down. Okay, looks like I need to just re-trigger that or just adjust the time base. Trigger, yeah. I have it triggered, okay. So that is definitely behaving differently. Let's put the modulation on. So we'll turn this up. Something definitely happening there. Let's increase the, or rather decrease the time base. Yeah. That's that kind of strange clipping effect we had on the other scope. But yeah, that's basically amplitude modulator. You can see it there. Put the trigger down there. That's where it goes into clipping. So the two scopes definitely behave quite differently. Let's put some music on with this one and see what we see. Okay, so some music playing now. Let's alter the time base again. There. Turn the amplitude down a bit. I think I'm clipping it. So you can see that in actual fact the digital scope doesn't really work as well in this way compared to the analog scope. I don't think so, at least. Okay. I mean, we seem to have whole breaks in the signal there. Let's just alter the level a little bit. Yeah, that is definitely behaving differently to my analog scope with that signal. I won't affect the signal here, I'll just leave it the same. In fact, let's just put it somewhere like so. Okay, let's switch back to the analog scope. Okay, I think you can see straight away that it's reacting in quite a different manner. Okay, than the digital scope. Interesting. So we could use this like a low powered transmitter basically to an AM radio. I don't have one to hand, but yeah, we could do that with it. But my interest of seeing how well digital scopes react to this sort of signal, I think, is quite worthwhile, especially when I'm reviewing them in future. So I think I'll probably get my hands on one of the other models. In fact, let's go for the FM shortwave and medium wave one. Yeah, let's try that. If you guys are interested, then let's do the same sort of experiment to see how well the oscilloscope reacts to it. Yeah, I'm sure one other thing you might be interested to see here, and that's what's inside the box. Let's have a look. Well, that's what we have inside it. So we can see the potentiometer with the switch. We can see the other one, which is just a potentiometer. Okay, the various, what are these things down here? Because they're not connectors or anything. Okay, there's some things down there, little transformers or something even. Okay. This seems to be just held down by this control, basically, from what I can see. Okay, what we got? Wow, I would say these are actually hand assembled. Actually hand built. This must be the space for the FM. So for the other version we have one chip on here. LM358. Okay, probably why there's an oscillator, I guess. I don't see anything else really that would oscillate. There's something here glued. Okay, so that's what's actually inside it, just an LM358, couple of transistors. So that's interesting because this device here is not that. Yeah. I mean, actually, this has a speaker on. This is more like a receiver. Is that what it's supposed to be? I'm going to have to translate this now and have to see what it says. Okay, so that's what is inside it anyway. And these things, I'm not totally sure what they are. Let's see. So 465 kilohertz IF frequency signal, audio signal injection method. Set the signal generator to medium band. Well, this is just medium band. Set it to 465 kilohertz. Inject the IF frequency into the IF frequency amplifier and frequency conversion stages of a superhet radio. For silent faulty machines, you can see where the signal is not passing through. For machines with sound but need to adjust the IF frequency, you can adjust the frequency step by step. In addition, at this time, the signal generator has radiated signals. As long, try to get more of it into the shot. As long as the signal generator is close to the radiomagnetic antenna, the IF frequency signal can be connected to the frequency conversion stage and the sound of the audio can be heard. In theory, the radio can receive the IF frequency signal in the entire frequency range because the antenna coil has limited suppression of the IF frequency signal. But the sound is lower. Okay. You can only move the signal generator close to the radio antenna and adjust the IF frequency step by step to obtain the maximum level. Okay, so it's telling us basically how to use it. This schematic is nothing. It's not a schematic of this thing at all. I said it looked more like a radio because it's a speaker. So it's showing you where to inject the IF signal. Injection points look on the various stages of the IF, intermediate frequency amplifier stages, so you can align each one in turn. Audio signal injection point, so you can test the audio amplifier. Okay, and then the last bit for low level, I think this means audio frequency inspection of the radio. You can output the audio signal from the low frequency output on the signal generator, connect the audio signal to the audio amplifier and check one by one to find the fault point. Okay, yeah, so it's basically telling you for a typical radio how to just test this part. So effectively, this is the RF stage. This is the stage of the amplifier, the radio frequency you're receiving. There's a local oscillator. It mixes the two frequencies together, and it's done in such a way that the local oscillator is always 465 kilohertz above usually the incoming RF frequency. So all this lot runs at 465 kilohertz, and you can set this generator to 465. Inject a signal here, for example. Do you hear any audio coming out? If so, you can come back to the stage before. Do you still hear the audio? You can alter the little transformer, the adjustable these. It might be out of adjustment and so on. You can work your way back. If you don't get any audio here, you can feed the audio output from the signal generator to here, and you can test the audio output stages first. So yeah, this allows you to work your way back through a radio, any radio, step by step, all the way to the RF stages. And actually, that's a pretty good beginner's guide to how to repair radios, yeah. Okay, that might sound a bit convoluted, so let's put that into English, so as to speak, yeah. So, principle of radio, and for that matter, television and satellite and everything else, that's radio transmission. So you have an antenna, and that's connected sometimes to an RF amplifier stage. So in the receiver, the first stage amplifies the RF frequency, okay? And then that goes into a mixer. And what the mixer circuit does, it takes, put some arrows so we get the direction of flow, a local oscillator, or LO as it's called, or abbreviated, okay? And the mixer mixes these two frequencies together, and what comes out of the mixer is four things. So you get the original RF frequency, or in this case it would be all of the RF frequencies, the whole band, okay, because it's not tuned to any particular frequency. So coming out, one is the RF, two is the local oscillator frequency, three is the difference between the two, and we'll call this IF, or intermediate frequency. You'll know why in a minute or three. Intermediate frequency, okay. And four is the sum, which is the sum of the two frequencies added together. Now if you think about this, because there's a whole wide band of RF frequencies and there's one local oscillator, then there's a whole load of sum frequencies and a whole load of intermediate frequencies, the differences, yeah? But what we can now do is we can select one of the difference frequencies, and that goes into the IF amplifier. So we amplify a specific difference frequency between the two. In the case of the AM radio, 465 kilohertz is the IF frequency, okay? The frequency that we filter out of the whole band. So basically what this means is, usually the local oscillator is higher than the RF frequency. I mean, it could be lower because the difference is the difference. But what it means is that any radio signal, a radio station, that is 465 kilohertz higher in frequency than the local oscillator is amplified by the IF amp, and all other radio frequencies are ignored, they're blocked, they're filtered, okay? So coming out of the IF amp is just always, and there's several stages of this, so you'll have several valves, vacuum tubes or transistors all amplified and tuned at this IF frequency, 465 kilohertz, okay? So only signals on that frequency pass through the amplifier, the IF amplifiers, and everything else is rejected. So by changing the frequency of the local oscillator, you are selecting an RF signal, which is 465 kilohertz, less than whatever this is, yeah? So by altering the frequency here, you can scan across the band, and that's how it selects a channel, okay, a radio channel. And this will go, well, in that example we saw in the Chinese things, you went through 3 stages of amplification. And the reason they do this, by the way, as well as being able to tune one of the signals by changing the local oscillator frequency, is that it's easier to make an amplifier that will amplify well at one frequency only than it is to make an amplifier that will amplify well at a whole range of frequencies, which is what the radio stations are on. Yeah. So these amplifier stages can have very high gain and very good rejection of other frequencies, if you like, interference. Okay, so that's what we have. And then the amplified IF frequency, which has got your radio station on, always at that frequency, goes into a detector, which effectively is a rectifier. It just rectifies the signal and it removes the high frequency component, and what you're left with is the audio. So you effectively filter out the IF frequency once you've rectified it, okay? And that gives you the audio signal going out, IF going in, obviously, yeah, in, audio out. And this is your audio amp, or AF, audio frequency amp, and this goes to your speaker. So that's how the radio works. Now, what that Chinese thing was telling us, it was showing us a typical circuit diagram of a radio, yeah, receiver, and it said that if you set your to 465, okay, kilohertz, and you modulate that signal with audio, AM, amplitude modulated, yeah, changing the amplitude which carries the audio signal, if you like, yeah. If you inject a frequency at that specific frequency modulated into the IF amplifier, you're bypassing all this. You are sending the signal directly into here, which is equivalent of what should be coming out of there if it's working, yeah. And by doing that, it helps you to diagnose a fault. So they were saying basically you could stick the 465 kilohertz modulated signal into here, and if it comes out and you can hear audio, then go back a stage, and if it still comes out you can hear audio. If it doesn't, there's a problem in this stage, and so on, working back, okay. If the IF stages are working, maybe your local oscillator isn't running, there's some problem with the mixer circuit or a problem with the RF amplifier, if there is one, okay. Another thing it was mentioning was that you can actually, if you put the thing close to the aerial, send a radio signal in at this frequency, and it will pass through the mixer, because one of the things that comes out of the mixer is the original RF frequency. Even if the mixer isn't running, that may well come through, and that's what it's saying to you. But it's saying that it will come out at a lower volume because this circuit is kind of designed to reject signals on that frequency, okay. That's what it was saying. It also says that there's an audio frequency output on them, little generator as well, and you can feed that straight into the audio amplifier and you can diagnose problems there. So that's what it was telling you in English, and that's a quick, I've done it once before but a long time ago, intro to how radios work, or at least analog ones. So I think that was an interesting little device. It's very almost like a Heathkit thing from the 70s, but it works, and that certainly tells you how it works. I don't really do radio repair. I've done some, I understand the principles of it. Interesting to hear what you guys think for €30. And what do you think? Shall we try the other one? Shall we get the one which does the shortwave and FM band as well, and then see how useful that is as well? Yeah, maybe. What do you think? Or do the other one as well. And if for no other reason, I like this actually to see how oscilloscopes handle AM and shortwave FM signals. Can they deal with them? Because from what I've seen so far, even my Finersi was having a little bit of trouble with that, where the Rigol was doing somewhat better, but neither of them did as well as the analog scope. Okay, guys, interesting. What do you think down there? Hope you enjoyed this anyway, and I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.